I am D.T. Vimala, Assistant Professor, Department of Computer Science, working in St. Josephs College of Arts and Science for Women, Hosur. My topic is 3D geometric transformation in subject computer. In 2D, that is the transformations is moving the images from one position to another position. Same, this is also in your 3D transformations. Next, in the transformation, we are going to see about the translation, that is how to make a translation in 3D, that is a three-dimensional view. What is a translation? It means the movement of an object from one position to another. The translation is done using translation vector. There are three vectors and three-dimensional view. These vectors are in X, Y and Z. We can see in the image. Translation, the X direction is represented by using the translation vector Tx. Translation in the Y direction is represented by using translation vector Ty. Translation in the Z direction is represented using the translation vector Tz. If a point having coordinates in the three direction x, y, z is translated, then after translation its coordinate value will be x1, y1, z1. That is after translation. So how we are going to make a calculation means, if we are having three axes means we want to find a new position, that is where we want to translate. The new coordinate point is x1, y1, z1. How we get the value for that? That is x1 equal to x plus tx and y1 is equal to y plus ty and z1 is equal to z plus tx. That is, we are adding the three translation vector to the original coordinate. If we are having the 5 points means we want to take the 5 coordinate values and we want to make a translation for that 5 values. You can see the images. Next transformation is scaling. Scaling is used to change the size of an object. The size can be increased or decreased. The scaling, three factors are required: Sx, Xy and Sz. Sx is equal to scaling factor in X direction. Sy is a scaling factor in Y direction. Sz is a scaling factor in Z direction. Thus we see in the 2D transformation we have Sx and Sy. In the 3D transformation we have one more axis, that is an Z axis. So we have one more scaling factor Sz. That is Sx, Sy and Sz is a scaling factor. See, the same process we are only doing in the scaling factor. We multiply the values in the 2D transformation. We multiply the values. No, it's the same process only we are also going to do here. So here we see how the scaling process is to be performed. Following are the steps to be performed when the scaling of the object with a fixed point ABC. It can be represented as follows. Translate the fixed point to the origin. Any values we want to translate the fixed point to the origin. Scale the object relative to the origin. Then translate the object back to its original position. See, first image that we are transferring the object to a origin, and second image we are scaling the object in X. Next, in the second image we are scaling the object, that means we are changing the size of the object. After scaling process we move to the original position. This is the steps for scaling in 3D transformation. Next transformation is rotation. Here the rotation is the moving of an object and angle. Movement can be anti-clockwise or clockwise. 3D rotation is complex as compared to the 2D rotation. For 2D, we describe the angle of rotation, but for a 3D, angle of rotation and axis of rotation are required. In the 2D rotation, we just use only the angle theta to rotate the object, but in the 3D transformation we need both the 3D angle and the axis of rotation to rotate the object. The axis can be x, y or z. In this image we can see here with the rotation of y-axis in the clockwise direction and the rotation of z-axis, here the rotation of x-axis but in the anti-clockwise direction. So we see the image, that is we are rotating the image that is in the x-axis and we move to the z-axis, that is the rotating the object in 3D transformation. Next, reflection. Reflection is also called the mirror image of an object. For this, reflection axis and reflection of the plane is selected. Three-dimensional reflections are similar to two-dimension. Reflection is 180 degree of the given axis. 180 degree of the given axis. Here, next is a shearing. Shearing, it is change in the shape of the object. Shearing means we just want to change the shape of the object. To change the shape of the object, we use the shearing transformation. It is also called as a deformation. It is also called as a deformation. And in the 2D transformation, we call it as a skewing. Here we know it as a deformation. Changes can be in the x directions or y directions or both directions in the case of 2D. The shear occurs in both directions, the objects will be distorted. But in the 3D can occur in 3 directions. But in 3D shear can occur in 3 directions. You can see the image, that is the first image the shearing in x direction, second image the shearing in y direction, third image that is shearing in x and y direction. This is the shearing in 3D transformation. Thank you.